With the law of cosines, it's easy to forget exactly how it looks, and there's three extreme cases to look at that are very informative, and they relate back to how I usually start the investigation of this. When we've got the law of cosines, let's focus on C, the version with angle C. You can always just change the letters around in here. It's just the crucial thing is that that's got to match this guy. This has got to be the side opposite this angle. I want to just look at three extreme cases here. The way I like to think about this, especially with this kind of analysis with these cases, is I'm going to think of A and B as fixed lengths, and I'm going to think of them as fixed rods, like wooden rods. Here's a hinge, so that's going to be opening and closing at angle C, and then a rubber band over here. And that just helps with the intuition, because we want to ask questions like, when the hinge closes and gets smaller, what does the rubber band do? Well, it gets smaller. When the hinge opens up and that angle increases, what should the rubber band do? It should get longer. That's the kind of thinking we want to be able to do. Okay, so in particular, let's look at three special cases. Okay, let me slide it in up here. Not a lot of space. What about when C equals, well, let's start with 90. I did it in a different order in class, but let's look at C equals 90 degrees, okay? So now this picture is going to become a right triangle. And of course we know what's supposed to happen there, although it's anything but a trivial fact. This C, we're supposed to get Pythagoras, okay? Do we? Okay, so that's what geometry says that. Now we want to check that against this algebraic formula. If we're skeptical about this formula, it should give us the right answer in that case. But what is cosine of 90 degrees? It's 0 if we know our unit circle. In that case, this all goes away, and we get Pythagoras. Okay, so that's definitely a huge check. And it's, most people think of the law of cosines, they often describe it as a generalization of Pythagoras for that reason. Okay, so now what about, let me put back the law of cosines in its full form. Okay. But let's look at the case where C is 0 degrees. Okay, that's where we have two sticks, and we let the hinge close completely, so it's not even really a triangle anymore. You might think, oh, it couldn't work then. Well, it does. That length is A, that length is B. I'm going to draw them with A being longer than B, but in a minute we'll see why that's not super important. Okay, and then C degenerates, the rubber band is fixed to these ends. Remember, the hinge is still here. Here's the rubber band, so the length of the rubber band C is just this. So it's just basically distance between points on a number line. We get that C is A minus B. Now, if A had been smaller and B had been bigger, we would get negative. To fix that, we remember, oh, the real version of distance between points on a number line is the absolute value of the distance between these guys. Okay. Now, what about this? So this is what the geometry is telling us. That looks very different from this, but wait a minute. What's cosine of 0? It's 1. And so this can go away. Well, these still look very different, but wait a minute. This, we should we should recognize this. It's A minus B quantity squared. Oh, and that's C squared. Well, okay, what happens if we square both sides of this to check? C squared is the absolute value of A minus B squared. But you know what? When I have an absolute value and I square it, I don't need the absolute value anymore because squaring it already makes it positive. And so indeed, these guys totally agree. So the extreme case is really just recovering A minus B squared, and that's exactly what C should be in this case with 0 degrees. Okay. So now let's go back. Well, let me just erase. Let's do one more case. C, angle C, equals 180 degrees. That's the other extreme, where the hinge is all the way opened out. Okay. Now A and B are in opposite directions. And the rubber band is all of that length. So geometrically, C is just going to be the sum of the two lengths. You know what? Let's just square that right off the bat. That's almost certainly going to be interesting. Hey, I get A squared plus B squared plus something. That's interesting. Well, what does law of cosines say? The algebraic formula gives us c squared is a squared plus b squared minus, oh wait a minute, is that going to screw us up? Minus 2ab cosine c. Oh, but wait a minute. What's cosine of 180? It's minus 1. Remember on the unit circle, that's all the way over to here. That's minus 1. So this goes away but changes that sign to a plus, and we're good. Okay. So those are 3 extreme cases, and they all fit into this pattern of the rubber band is smallest when the angle's 0, it's medium, its Pythagoras value when the angle's 90, and it's the biggest it can possibly get, the sum of the 2 lengths. Can't get any bigger than that for the third side of a triangle when the angle opens all the way out to 180. So I love doing this because it really convinces us that this law of cosines thing has something going for it.